The James Webb Space Telescope has made an extraordinary discovery that has captured the imagination of people worldwide. It detected lights that seemed to shine as if from a distant city, flickering from a point about 4 light-years away. This finding has reignited global curiosity about the existence of intelligent life beyond our planet. By focusing its powerful instruments on Proxima Centauri B, the closest known exoplanet to our solar system, the telescope observed unusual bursts of light that defy current explanations. These flashes raise the tantalizing possibility that they might be signs of an alien civilization, and the world eagerly awaits more data to better understand what these signals might mean. For many years, both scientists and the public have been fascinated by the potential of life existing elsewhere in the universe. Any hint from scientific observations that supports this idea tends to spark widespread excitement and speculation. The James Webb Space Telescope marked a significant milestone by providing evidence suggesting that life might indeed be out there. While surveying the cosmos, it detected light patterns on Proxima Centauri B that resemble city lights, implying they could be artificial in origin. This idea has deeply intrigued researchers who see it as a possible breakthrough after decades of searching. If confirmed, these signals could indicate intelligent beings who have developed complex societies far beyond what we currently understand. These city-like lights, visible from a staggering distance of 4 light-years, have amazed NASA engineers and raised profound questions. How long have these signals been traveling through space, waiting for human technology to finally detect them? Astronomer David Kipping from Columbia University described Proxima Centauri B as an unusually complex world. Unlike typical rocky planets that absorb sunlight and emit energy as infrared radiation, Proxima B behaves differently due to its unique interaction with its star, Proxima Centauri. This distinction highlights the crucial role of the James Webb Space Telescope, whose ability to detect infrared light was essential in identifying these strange radiative patterns. Scientists plan to continue monitoring Proxima Centauri B closely to understand its atmospheric conditions and evaluate whether it could support life. The telescope's advanced sensitivity to infrared wavelengths allows it to observe the planet's night side, something few other telescopes can do, capturing even the faintest glimmers of light. This precision is vital to determining if the mysterious lights are truly artificial. If these lights emit within a narrow frequency band that differs from natural stellar emissions, it would strongly indicate they come from an intelligent source. Proxima Centauri B has a dynamic relationship with its star, experiencing a day-night cycle similar to Earth's. During its 11.2-day orbit, the planet undergoes intense heat on the side facing the star and significant cooling on the night side. These temperature swings depend heavily on the planet's composition. If Proxima B lacks a substantial atmosphere, the temperature difference would be extreme, scorching on the star-facing side and freezing cold on the dark side. This dramatic thermal contrast is of great interest to astronomers because it provides key clues about whether the planet has an atmosphere and what it might be like. Thanks to its ability to capture detailed infrared images, the James Webb Telescope can analyze the planet's thermal emissions, offering valuable insight into its atmospheric makeup. Another advantage is the timing of the telescope's orbit, which aligns closely with Proxima B's 2-week cycle around its star. This synchronization enables consistent, detailed observations of the planet's light and temperature changes over time. If an atmosphere is detected, scientists will then focus on studying its chemical composition to determine if it could support life. Detecting molecules such as oxygen, methane, and water vapor would be promising signs. To do this, researchers examine the starlight that passes through the planet's atmosphere, a complex but essential process. While the James Webb Telescope excels at detecting elements like carbon dioxide, methane, and water vapor, It has limitations when it comes to identifying free oxygen, a key indicator of biological activity. However, it can search for ozone, another molecule that suggests a potentially life-sustaining atmosphere. As data from the telescope continues to pour in, the quest to explore distant worlds pushes forward, bringing humanity closer to answering one of its most profound questions: are we alone in the universe? It's important to note, though, that the James Webb Telescope can only observe a limited number of exoplanets close to Earth. For more comprehensive studies, astronomers are preparing to use next-generation ground-based observatories like the Extremely Large Telescope, expected to be operational by 2028. This new instrument will offer deeper insights into the atmospheres of faraway planets, providing clearer and more detailed information about their potential habitability. Meanwhile, the James Webb Telescope remains a cornerstone in exoplanet research, delivering groundbreaking discoveries despite some limitations. Scientists are also working on developing advanced space telescopes capable of reducing starlight, which would significantly improve our ability to detect the faint glow of planets orbiting distant stars. This technique is similar to shielding your eyes with your hand to better see an object by blocking out bright sunlight. By dimming the overwhelming glare from stars, these instruments can more effectively study exoplanet atmospheres and determine if they might support life. However, this goal presents significant technological challenges. Stars shine millions of times brighter than their planets, making it incredibly difficult to spot the faint planetary light nearby. To overcome this, researchers are creating innovative technologies like coronagraphs, devices built into telescopes that block direct starlight while letting light from orbiting planets pass through. These devices manipulate light waves with extraordinary precision to reduce stellar glare, revealing the subtle light from distant worlds. Another promising technology is the Starshade, a massive, flower-shaped spacecraft designed to work in tandem with space telescopes. Positioned tens of thousands of kilometers away, it blocks starlight before it even enters the telescope's view, allowing only planetary light to reach the sensors. This approach shows great potential for observing planets in their stars' habitable zone, where liquid water and possibly life could exist. Such technological advances require incredible accuracy. For example, aligning a starshade demands precision within fractions of a millimeter across vast distances. These instruments must also be lightweight, energy efficient, and durable enough to withstand the harsh conditions of space. Despite these challenges, the potential rewards are enormous. Successfully observing and analyzing an exoplanet's atmosphere could reveal biosignatures, chemical traces that hint at life. Certain gases, like oxygen, methane, and water vapor in specific combinations, might provide compelling evidence of biological processes on other worlds. Researchers are also developing ways to capture sharper, direct images of distant planets. Future telescopes could use advanced adaptive optics to correct distortions caused by Earth's atmosphere or telescope movements, resulting in clearer views. Combined with starlight blocking technologies, these improvements might enable scientists not only to detect exoplanets, but also to map their surfaces and study their climate systems. The advancements in space telescope technology represent a monumental leap forward in our search for life beyond Earth. By enhancing our ability to study distant planets, we move ever closer to answering the timeless question of whether humanity is alone in the cosmos, a discovery that could fundamentally transform our understanding of our place in the universe. What do you think about the possibility of intelligent life existing somewhere beyond Earth?